Okay, in this first of our three-part series on Green's theorem, we're just going to set up the preliminary things we need to do in order to start doing the real explicit calculation. The idea is we have a simple closed curve. We're going to call that curve C. Now, it needs to be an oriented curve, which means there's a direction, and we're going to pick counterclockwise. Now, counterclockwise means as you're walking along the curve, the inside of the curve is always to your left. Now, it needs to be a closed curve, which means it starts and stopped in the same spot. It needs to be a simple closed curve, which means it doesn't ever cross itself more than once. Just the only places they should touch are the starting point and the ending point. And we want to calculate the work done around it by a vector field. Now, the vector field should have the same kind of notation we're used to seeing, but let's just write it down. It should be f1 xy times I plus f2 xy times j, like this. Now, we want to do this the fundamental theorem calculus way, and you would think we would chop the curve up into little tiny pieces. We're not gonna. What we're going to do is way on the inside somewhere, we're going to pick a very small rectangle. And what we're going to do is calculate the work done by our vector field going counterclockwise around that little tiny rectangle. It'll be amazing actually how this works. Let me blow up the little